Welcome back, guys. We're just doing a bit of work here out of the textbook, and there's two exercises in this chapter that deal with adding fractions and also subtracting fractions. I think the key thing to remember here is that addition and subtraction are opposite operations of each other. So to me, they go together, and I think we can talk about them together. And the key thing I want you to be very careful of is to look, because I see the most common mistake being made is that students do not look to see if it's an addition sign or a subtraction sign. They do some work and they're perhaps adding fractions, and so they move on to the next question and they keep adding them, and they've just forgotten to look carefully, and they don't notice the subtraction sign, so they're getting them wrong. So bear that in mind, and I'll get behind the light board here and show you hopefully a few moves that you can use to help you speed up that whole process. Okay? We're working on adding and subtracting fractions here. I'll put this together in one video. It'll be two separate exercises in your textbook. But it's a good thing. It sounds so obvious. I want you to stop and look for the plus sign or the minus sign, because I see that as a bigger source of mistakes. Students are just rolling on from one question to the other. They might have a plus sign stuck in their head, and that's not what the question's asking for. So just be really careful. And again, scan the question and look for these things. Look for if the denominators are the same. Really simple. We'll stick some numbers up on the top in a moment, but life is easy when the denominator's all the same. All right? It's all the action is up on the numerator, and you just have to go along and add all these things in. Now, my tip in this case is, let's make one the vinculum longer, if you like, and we're adding 3 plus 7 plus 4. Sit all that work up there, okay? And as kind of one fraction, okay? Because then we can just come in here and have a look at this work here. We already know the answer is going to be something on 11. So 3 plus 7 is 10, plus 4 is 14. And depending on the question, it may ask you to write that as a mixed number. So that's the same thing as 1 and 3/11 as our final answer. So that situation is kind of easy. Okay, so the next situation we're in is this idea that the denominators are going to be different, and we call them not like or unlike or something like that. So what do? We need to the lowest common denominator is the best. I said is the best, but any denominator will do. And obviously the fastest and easiest thing to do is just look at the denominators and multiply them together. Okay, so let's set up two fractions here. We've got 7 on 10 plus 3/4. And if we wanted to do that, we could make a fraction on 40. See how I put the plus sign there? Now I need to come back and do a little bit of work here. 10 times 4 is 40. I'm transferring that information up onto the numerator, and 4 times 10, and I'm transferring it up here, because now that's important, that creating in this step, I'm creating equivalent fractions. Now that I've done that work, I can just read this off as 7 times 4, which is 28, plus I've already got the plus sign there. 3 times 10 is 30. Add those things together and I get to 58 on 40. And I can rewrite that as 1 and 18 over 40. Now, that fraction, part of the fraction, is not in its simplest form. 2 is a common factor, so I can write that as 1 and 9 on 20. That's my final answer. So, that's one way. Let's do the same question again, but this time we'll find the lowest common denominator, and we have 7 on 10 plus 3/4. Now, what I see there is if I multiply this by 2 and this by 5, I get the equivalent fractions on 20, and that'll be my lowest common denominator. Okay, so just transfer that information back up there. And so I end up with 14 plus 15, and that's the same thing as 29 on 20, and that's 1 and 9 on 20 as well. By doing that step of finding the lowest common denominator and thinking carefully about that, it's just saved me an extra step. I don't need to do this step in here. We all end up in the same place, but it's just nicer and faster and more convenient if we do the critical thinking step right here by looking at the denominators here and making a decision and finding the lowest common denominator here. Okay, we're back with another question. I'm going to do this 2 ways. And the first way, I'll shift it over here, and I could possibly do this. I could go 5 minus 3, so deal with the whole numbers, and then I can go, I'm going to add, and another bracket here, 2/3 minus 1/4. And this is just, those brackets are just helpful to let me see what I need to do. So 5 minus 3 is 2. That's the whole number part taken care of. And here I can see straight away the denominators aren't the same. So I'm thinking I'm going to set this up as something over 12. I'm going to times this by 4, times this by 4, times this by 3, times this by 3. There's a subtract sign in there, so I'm going to put that in there right now before my mind gets distracted by the work that I need to do up here on the numerators. So this is the next bit of work. 2 times 4 is 8. Subtract 1 times 3 is 3. So this works out really nice because the final answer will be 2 and the fraction part here will be 5 over 12. So there's our answer. And that works out nice and neat to split it up like this. What might not work so well is if I just quickly change one of these numbers to perhaps 3/4, and this becomes 9. And so we're in a little situation here underneath here. I'm pointing this out because I want you to see this technique causes a few troubles when we're in this situation here. We've got 8 subtract 9, which is minus 1/12. So we have to come back into our whole number and think about this as 1 plus 12 on 12, subtract 1 on 12. And that's a little bit messy because now we're at 1 and 11 on 12 is our final answer. And this part in here causes some troubles. And this negative sign here causes some issues. So what I'm going to say to you is perhaps the fail-safe method or something that's going to work every time is if you convert these guys to improper fractions first. So let's do it over here. I'm thinking 5 times 3 is 15. 15 plus 2 over 3, subtract. That was the denominator, there was 4. 3 times 4 is 12 plus 1. It's a step you can do in your head if you like. I don't mind. Or you can set it out like that. I really don't mind. And now we're at 13 over 4. The numbers are a little bit bigger here, so you know, there's a cost to this if you like. We've got to times this by 4. We're creating a fraction over 12, and we've got some work to do here. I'm going to set it up. I'm going to free up my mind as much as I can to do the work that I need to do. So hopefully you can see there I've created a big line for the vinculum, for the fraction. I've put the minus sign in there, and if you like, I've got 2 boxes now that I have to work out the numerator for. So one of these is easy. I'm looking at that one first because 13 times 3 is 39. Now 17 times 4 might cause some issues here. So times by 4, I like it because we can double. So we've got 17, we double that to 34, and then we double it again to 68. So we've got 68 minus the 34, and we can do our subtraction here. The numbers are a little bit bigger, granted, but it's hopefully we'll end up in the same place. I'm thinking about this as 68, take 40 plus 1, so we get to 39, and 29, and I'm thinking about this as 29 as 24 plus 5, so it's going to go in twice. 5 left over, so 5 over 12. So these two answers are the same. We just chose different ways to get there. And I think converting to improper fractions is kind of like the fail-safe method of doing this. But there is a cost sometimes, and the cost is you have some larger numbers to multiply and or add or subtract, okay? But it avoids this situation with some of the fractions where we end up with this subtract a number here, and then we end up having to think about these little maneuvers here to get to our final answer. So I hope that helps you.